You might already know that if you multiply root 2 times root 2, you get 2. Now, what you may not usually think is going in the reverse direction and say 2 can be written as a product of these factors. And that could be a useful thing, because if I want to rationalize, say I'm given this problem, 2 over square root 2. Then if I can see this numerator 2 and break it down into its factors, then one of the square root 2's will cancel with the denominator, and there is my answer, root 2. Let's look at one other example. Say 14 divided by square root 7. So when we think of 14, we think of 2 times 7, and then we say, oh, we can't go any further. But 2 times 7, and since I have a square root 7 in the denominator, I want to break that 7 as root 7 times root 7. And there you go. We can cancel the root 7 in the denominator with 1 in the numerator, and that's our answer, 2 root 7. Now let's take one other example. Say we have 10 over 3 root 5. In that case, I want to see 10 as 2 times 5. We already know that, but that 5 could be broken down into root 5 times root 5. And now notice I can get rid of one of the root 5's, but there's a 3 in the denominator. So my answer is 2 root 5 over 3, but this is still okay because we don't have square root in the denominator. And that's what rationalizing the denominators mean. Now, but does this method always works? Can we always get? And the answer is no. Sometimes what you have is 3 over, say, square root 7. Now, you can't break this 3 and have square root 7. In that case, we do the usual, introducing an additional root 7 in. So 3 root 7 over root 7. So this is the time we'll have to do what we are used to doing, multiply and divide by root 7. Now here are some problems that I have written down. Rationalize the denominator. So 30 over square root 5. So it has 5. So I want to have 5 up here. So I'm thinking 6 times 5, but that 5 I'm going to break down as root 5 times root 5, and the answer is simply 6 root 5. What about here? 15 over 5 root 3. So 15 can be written as 5 times 3, but that 3 can be written as root 3 times root 3. And look, we can get rid of the common factor 5, and one of the root 3's will go away. So that will give us root 3. Now what about this one? 10 divided by 3 root 2. Since I have square root 2, I want to have 5 times 2, but 2 is root 2 times root 2. And now we can get rid of one of the root 2's. The answer is 5 root 2 divided by 3. This is still rationalized.